again, this is a long question, all right? And someone says, where's it going? Going somewhere. We followed the instructions. Right? I answered the questions they had about this, and we got A done, not that bad, but it took some effort to get through it. We got B done, that was some effort too. We got C done with less effort, and now I'm on to D. And D says find the minimum value of f of t. This largely depends on your ability to look at the function and take its derivative at this point. And then again, after I do that, they say, show that the equality blah, blah, blah holds for some real value of A, if and only if D is greater than or equal to some value, which you should identify. All right? Now, granted, I always say if you can't understand what you've read, try to parse it and get something down. And I'll go through that with you now. And I'm parsing the language. We got the f of t, if you remember. And I'll write this over here. F of t is the cube root of 4. And then it's going to be 1 plus t over the cube root of t squared. Now, by the way, I have opinions about what to do when it takes derivative over here, but we're trying to minimize this over here, which means I'm going to take a derivative. All right, before I do that, though, I want to just remind you about what the t is. The t equals a squared. That was a given. I know a is greater than 0, so I certainly know that t is greater than 0 as well, by the way, looking at that. All right? So my analysis is going to go for the t greater than 0, but I have a preference for writing these things in a little different way, by the way. And you may say, I don't like what you're doing, but I'm going to write it so these have exponents in it. So the first thing is going to be t. It's 1 divided by the cube root of t squared. It's going to be minus 2/3. Let me just make sure I said that right. Yeah, 2/3. Yeah, minus 2/3. And then it's going to be plus, well, I got to pay a little attention to this one. It's going to be 1 minus 2/3. And that's going to be 1/3. Now, so why'd you do that? It's so much easier to make that guy's derivative than the other guy. The other guy's a quotient. And it got a root in it. I don't want to deal with that, by the way. So I'm going to write down f prime of t. But I want to point out my analysis has to take place on this over here. So we'll do that in a moment. So what do you get? The cube root of 4. And I got to differentiate the inside, and that's going to be minus 2/3. And then I can take 1 from the exponent, right? That's going to be minus 5/3. And then it's going to be plus 1/3 t to the, I'm going to take 1 from that, right? Minus 2/3. Well, I do need to analyze that. And that's going to be the cube root of 4. I'm going to factor out a 3. I'm going to factor out t to the minus 5/3. Again, these are preferences. You may not share those preferences. And you're going to get, let's see, minus 2. That's from this term over here. On the other guy, I'm going to get what? I think it's going to get t, right? There's t to the first power. That's 3/3 minus 5/3 would be minus 2/3. So this derivative didn't turn out too bad. Now, if you want to rewrite this a little differently, you can. You can write it as a cube root of 4, t minus 2, and the bottom is going to be t to the 5/3, by the way. All right, my analysis for this thing over here, I'm looking at the derivative, and my t's must be above the 0. There's only one critical value over here, and it's 2. All right, it's 2. So then the question is, what do you do with this thing? You analyze it, and you're going to plug in. And we're going to plug in, I think I'd plug in a 1 over here. And if I did that, what would I get? I get a negative number. I'm plugging it in here, by the way. And then I'd plug in, I don't know, 3. What do you get over there? Positive number. What does it mean? It's decreasing, and then it's increasing. So I'm going to say I found a minimum at t equals 2. A minimum of what, though? A minimum of the d to the 2/3 power. All right? Again, I want to go back over that with you, that this was actually d to the 2/3 power. So I'm going to say it's a minimum of the d. And certainly I want to make sense out of this now. And so how do you make sense out of this thing over here? It's the t is equal to 2. I want to remind you, though, the t was equal to a squared. The a was a positive number, by the way. So if you get 2 equals a squared, and a is a positive number, the a is going to be the square root of 2. Right? That's what the a is. All right? So I'm going to say, if you thought about this over here, you got your parabola over here, and what did we just do? We minimized the distance of a normal line going through that, and the distance here would be the minimal distance at this point. And what does that occur? When the a was root 2. But I'm not going to worry about this too much, all right? But this over here is the distance now, all right? So I'm going to say root 2. But again, I want to talk about the distance now. And if this is the minimal distance, I got to figure out the distance now, all right? So I want to go back over here and just review that with you. And the d, let's see if we can do that. I got to find out where that is, by the way. Yeah, it's not that bad to do, by the way. And I'm actually going to use this over here. And the t is equal to a squared. I'm not going to use that one. Let's see what the easiest one to use is. I want to go back and use that. But I do have to discuss that d, don't I? Well, let me do f of t. What's f of t? Cube root of 4, t plus 1, over cube root of t squared, and that equals the d to the 2/3, by the way. All right, let's see if we can figure it out. All right, what I find out for my t was 2, right? Doesn't look that bad, by the way. So cube root of 4, the t is 2, right? So it's 3. This would be the cube root of t squared would be what? If t is 2, that's 4. Boy, isn't that convenient. This cancels off. And what do you have here? 3 equals d to the 2/3. And now I'm going to raise both sides to the 3 over 2. And what do you get there? You get d. And then what do you get there? You get the square root of 27. But if you prefer, you don't have to write that down. You could write down 3 root 3. So what I know now is this is the minimal distance, so the d is always going to be greater than or equal to 3 root 3s for that normal line, by the way. And the d is going to be the distance between that normal point over here, which is that a, and that a can vary. The a can start up at 0, but it can't be 0 and going this direction over here. And I'll provide a better picture for you, all right? But we're done. Thank you.